Today's lesson is called The Basic Concepts of Probability. So remember the union rule of sets from a previous section about the cardinality of sets A and B in a sample space S? We have the n of A union B equals n of A plus n of B minus n of A intersect B. Remember we had to remove the parts that we counted twice in n of A and n of B in the n of A intersect B. So assuming that the events of this sample space S are equally likely, I want you to divide each one of these terms by n of S in this equation. And then we're going to rewrite that as probability. So if I divide by n of S, the sample space, n of A union B over n of S is simply the probability of A union B. N of A over n of S is simply the probability of A. N of B over n of S is the probability of B. Minus n of A intersect B over n of S is the probability of A intersect B. So this is what we call the union rule for probability, which states for any events A and B from a sample space S, we can have the following formula. Probability of A union B equals probability of A plus the probability of B minus the probability of A intersect B. Now this works for all events, mutually exclusive and not mutually exclusive, but we're going to talk about what mutually exclusive means and how we can use a more simple formula when it's mutually exclusive. And when it's not mutually exclusive, we have to use the full formula. So when two events cannot occur simultaneously, the events are called mutually exclusive. For example, suppose you randomly select one card from a 52 card deck. Let A be the event of selecting an ace, and B be the event of selecting a king. Only one card is selected, so clearly it is impossible to both get an ace and a king at the same time. There are no cards that have both ace and king on them. Therefore, A and B are mutually exclusive. And if A and B are mutually exclusive, then our probability for A union B is simply probability of A plus probability of B. No need to subtract off the probability of A intersect B from mutually exclusive events, because they can't happen at the same time. So there is no probability of A intersect B. That would be just 0. So we can simply not add that to the end of our equation. So here's an example. Suppose a jar has 4 white marbles and 3 red marbles and 3 blue marbles. Find the probability of selecting a white or red marble. So in my jar, we said we have 4 white, 3 red, and 3 blue for a total of 10 marbles. If I'm trying to find the probability of white or red, I need to first determine if these events are mutually exclusive or not. Well, can my marble be both white and red at the same time? No, so definitely they are mutually exclusive. So I can use the formula, the probability of white plus the probability of red. No need to subtract off the intersection because the intersection would be 0. There's no possible way of the marble being both white and red at the same time. So the probability of white is 4 chances out of the 10, plus the probability of red is 3 chances out of the 10. So the probability of white or red is simply 7/10. Next, we're going to talk about not mutually exclusive. It is possible to find the probability of two events where events A and B are not mutually exclusive. For example, suppose you randomly select one card from a 52 card deck. Let A be the event of selecting an ace, and B be the event of selecting a red card. Now, it is possible to select an ace and a red card at the same time. The ace of diamonds and the ace of hearts are both red and an ace at the same time. Thus, A and B are not mutually exclusive. So if A and B are not mutually exclusive, then you need to use the full formula. Probability of A union B equals probability of A plus the probability of B. Subtract off the probability of A intersect B because you counted those twice. So our not mutually exclusive example, suppose you randomly select one card from a deck of 52 cards. find the probability of selecting a spade or a king. So a spade and a king are not mutually exclusive. There is a possibility that you could have the king of spades, which would be both a spade and a king at the same time. So we're going to use the full formula. We're going to take the probability of getting a spade plus the probability of getting a king minus the probability of getting a spade and a king, because you accidentally counted those twice in the first probability and the second probability. So the probability of getting a spade, well, we have 13 spades in the deck of cards out of 52, plus we have 4 kings out of the 52, minus there's only one king of spades, so there's only one that is both a king and a spade at the same time. So we have the probability of being a spade or a king is going to be 13 plus 4 is 17 minus 1 is 16 over 52, which if I divide by 4, that gets me 4 over 13. So that's how you're going to use the formula if it's not mutually exclusive. Find the probability of selecting a red 7 or a black 8 from a 52 card deck. So the first thing I want to do is decide, is this mutually exclusive or not mutually exclusive? Is there any possible way of getting a red 7 and a black 8 at the same time? Well, no. Red 7 and a black 8, those are totally different cards. You can't get those at the same time. So we would call this mutually exclusive. So because it's mutually exclusive, I can use the shorter formula, which we have the probability of a red 7 or a black 8 is simply going to be the probability of a red 7 plus the probability of a black 8, and then that's it. No subtracting off because there's no intersection between those two things. The probability of getting a red 7, well, there's 2 red 7s. We have a 7 of diamonds and a 7 of hearts, so that's 2 out of 52. Plus, there are 2 black 8s, the 8 of spades and the 8 of clubs, so there's 2 there out of 52. So when I add that up, we get 4 out of 52, which when I divide the numerator and the denominator by 4, that's 1/13. So the probability of getting a red 7 or a black 8 is simply 1/13. Okay, next, find the probability of rolling an odd number or a number less than 4 on a 6-sided die. Well, is there any way that we could roll an odd number and a number less than 4 at the same time? Well, sure. A 1 and a 3 are both odd and less than 4. So we need to use the not mutually exclusive formula, which means we have the probability of odd or less than 4 is equal to the probability of odd plus the probability of less than 4 minus the probability of odd and or intersect less than 4. So the probability of odd. For the odd things, we have 1, 3, and 5 are the odd numbers, so that's 3 out of 6. For less than 4, 1, 2, and 3 are all less than 4, so that's again 3 choices out of 6. And then we're going to subtract off those that are both odd and less than 4, which 1 and 3 are both odd and less than 4. So that's 2 out of 6. So when I add all of those up, I get the full probability, which is 6 minus 2 is 4/6, which reduces to 2/3. So the probability of getting an odd number or a number less than 4 is 2/3.